when we're trying to find roots now, we're not really looking at square roots anymore. We're going to look at what we call nth roots. And going back to our definition of roots, it comes from exponents. If we have r to the n equals a, this whole thing is called the exponent. It has two parts. Remember, the base is r, and the power, or the exponent, is n. If we multiply that all out, it'll give us some sort of value, a. Now, the inverse of that is going to be the root. This thing, called the nth root. Now, as a whole, it's also known as a radical, but it has two parts as well. The base of the radical is actually called the radicand, and the power of a radical isn't called the power; it's called the index. And what it means, if we have the fifth root of x equals, 1, how about 12? Then what that means is 12 to the fifth power is equal to x, because these are going to be inverses of each other. Your book asks the question in this sort of way. It says, find the nth root of a when n is 4 and a is 81. What that means is, since we're finding the nth root and n is 4, 4 is going to be our index, and our radicand is going to be 81. And what we need to do is find out, what number r is going to give us that value. Now, by the definition, that means that r to the fourth power has to equal 81. So we can just kind of start guessing, check out 2 to the fourth power. Well, 2 to the fourth power is 2 times 2, which is 4, times 2, which is 8, times 2 again, which is 16. Therefore, r is not 2. If we look at 3 to the fourth power, well, 3 times 3 is 9, times 3 again is 27, times 3 one more time is 81. That means that r is equal to 3. So, the fourth root of 81 is 3. How about if n equals 3 and a equals negative 216? Well, that means we're finding the third root of negative 216. So once again, let's let it equal some number, r, and we're going to find out what that number is. That means that r to the third has to equal negative 216. Well, now, the number that we're going to have to pick has to be bigger than 2, has to be bigger than 3, so I'm going to jump up a couple and maybe take a look at 5. 5 to the third power, 5 times 5 is 125, times 5, or 5 times 5 is 25, times 5 again is 125, which is too small. And then we check out 6 to the third. 6 times 6 is 36, times 6 again is 216. Whoa, hey, look, 216, that's what we're looking for, right? Wrong. We're actually looking for negative 216, which means our base here would have to be negative 6 to the third power. That will give us negative 216. So, the cubed root of negative 216 is right here, negative 6. We can look at nth roots as exponents, as powers, and we call them rational exponents. So if we have the nth root, that means the power is going to be 1 over n. And so if we have a to the m over n, well, that's the same as a to the 1 over nth power times 1 over m, or time to the mth power again, which means we're going to have the nth root of a taken to the mth power, or we could rewrite it as this, the nth root of a to the m. Now, using rational exponents can help us out, because if we look at 4 to the 5/2 power, right, that's the same as 4 to the 1/2 power to the 5th power. Well, 4 to the 1/2, that's the square root of 4, which is 2. And 2 to the 5th is 32. If we had 9 to the negative 1/2 power, well, what does a negative do again? It takes the entire exponent and puts it in the denominator. Then the power becomes positive. So we really have 1 over the square root of 9, which is 1/3. What's even more helpful, though, going back to these two examples, is that by using rational exponents, we can plug it into our calculator, and the calculator can help us find these. See, if we wanted to find the cubed root of negative 216 again, we would look at negative 216 as the base, and the power would be 1/3. Now you can type that into your calculator using parentheses and then what we call the caret. So you look for this upside down V, then you would use parentheses again to type in the power. So grab your calculator and type this in exactly the way it looks, with the parentheses, the negatives, the fractions, and everything. You hit enter, and you end up with -6 for an answer. So try the next one as well. The 4th root of 81, rewrite it as 81 to the 1/4 power. Type it into your calculator using parentheses. 81 to the 1/4 power. Hit enter, and you should get 3. Make sure that you know how to do this on your graphing calculator. It makes finding nth roots a lot easier. Now we can use these bigger roots to help us solve equations. When I have 1/2 x to the 5th equals 512, we want to get rid of the 1/2, which we divide by 1/2. And of course, dividing by 1/2 is the same as multiplying by 2. Well, over here, these guys cancel, and we're left with x to the 5th equals 2 times 512, which is 1024. To get rid of a power, we need a root. So I'm going to take the 5th root of both sides. So the 5th root of x to the 5th cancel each other out, and we're left with x. And we have to find out what the 5th root of 1024 is. So take 1024 to the 1/5 power. Type that in your calculator. 1024 to the 1/5 power. What we get is 4. So x equals 4. One more. X minus 2, the quantity to the 3rd power, equals 14. Now the first thing that we want to get rid of is that 3rd power. So how do we get rid of a power? By taking a root. 3rd power and the third root and the 3rd power cancel each other out. So we're left with x minus 2 equals the 3rd root of 14. So type it into your calculator, 14 to the 1/3 power. And we end up with a crazy decimal. So x minus 2 is equal to 2.410142264. Finish this off now by just adding 2 to both sides, and x equals 4.410142264. Of course, we only need to go 3 places, and we're done.